Building up on the CTF playlist that we created last time, today I'm going to do a point challenge called Jump, and it's from the USIU CTF that we were looking at last time. So a great shout out to my new follower. Actually, remember this was 39 the last time we were here, so that's nice. Listing the current directory, we have Jump here, and you can check its file type using file utility, and this is similar to the previous challenge that we did. So we can also use rabin2, which is a binary from radare, and it gives us the information about this binary called Jump. So basically you can run it in Linux, and this is its interpreter. And something to note is the language used to write the binary is C. So that's awesome. We can use readelf to read the symbols, and we can see that we have the default symbols here, and we have some functions like main here. So we can filter out for the fourth field, which is function, using awk. So the way we do that, in the awk main part body, we can say if the fourth part, so that is if the fourth field equals to func. So func to represent the function, we just need to print the default record. Yeah, and we have that. So we can see main, and we can see an interesting get flag here. So we can use objdump to check the details of the get flag here. So this should be objdump tag D for print the disassembly, and then tag M to specify we need the Intel syntax, and less utility to get a nice view of that. So we need the get flag, and as you can see here, we have the full address. So basically, most likely the PIE is disabled because we have the full address. So we will know this address at runtime and before even the binary is run. So that comes pretty in handy. So you can see we are executing exec.We with some string from this address here. So we can use GDB to check that, and we can set the disassembly to Intel, and also we can set pagination to off. We can discuss get flag, and we can see this the string here, so we can examine the string from there, and we can see it's been SH. So if we jump into this function, of course we land into a shell. So disassemble the main function also, and you can see we are using printf, and we are printing a string from this address here. So examine the string from there, and you can see the drill. So that's pretty nice. From there we can see that you are not clearing the buffer after we print this. So basically there might be some issues when you are using pwntools. We are using gets here, which is pretty bad because you cannot specify how much characters you want to read. So you can see you are subtracting x70 from RSP, so that's 112 from the previous video that we did. So 112 to the RBP, and then the RBP is 8 bytes wrong. When you add that here, I bet that is 120 bytes long. So I guess that's the buffer, but anyway, we can always counter check that with using cyclic. So run, and then we need cyclic and 150 pattern, long pattern. Yeah, so in 64-bit binaries, basically the pattern that overflowed the address will not be printed here like in 32-bits binary, because this uses some kind of a funny way. So it will print the address where the segmentation fault occurred, but not the pattern. That's because we are violating the rules of canonical addresses. So basically these are the top addresses, 2 addresses that are used for the kernel. So what you can do is check on top of the RSP what is there, and we can use the string thing here and take the 4 bytes from here. So using that in quotes, we can see we have 120 bytes long buffer. Before we quit, of course, we need also to examine the get flag function, and we can see the address is the same. So yeah, let's quit. So for the script, it's just the normal things like we specify the author, it's me at trustability of course, and then the shebang line, so I guess that's the user. Trustability, then we can import from pawn import all. We can specify that the elf, we need the elf binary here is this guy called jump, and we can say check sec should be like off, false I guess. This should be false I guess, yeah, something of sort. So basically we can also specify the p variable to hold the process of this binary. Yeah, so from there we need something like p.interactive in the end to interact with this binary. So we can give executable bits to this binary, to this script of ours, and then run it. And you can see we have an interactive console. From there we know the offset, and we know this the address of get flag, so let's do that. So get flag equals to pack this into 64 bit, so literal Indian of course, and then we need the offset here, which is 120. For the payload, we are going to send an obsled of 120 length of 120 bytes. So you specify this to be in bytes, that's how Python likes it, and then you multiply by the offset I guess. Then from there you can add get flag. From there we need to send the payload, so p.send line, then the payload. That's nice. Yeah, and we get a shell, so that's pretty nice. ID, yeah, we have a shell. So shout out to my new followers, and share the content if you like it. So see you next time.